Alright, going to be solving by elimination, and the way this is going to work is we're going to be looking for something that will cancel out, something that is what we call opposites. I have a negative 2y up here, and I would need something that's the opposite of negative 2y, which we have, positive 2y, and we need opposites, and the reason they call this the elimination method is because I need something to cancel out. I need something to eliminate. So when I add these two equations together, which if we have opposites in the two equations, we'll simply add those two equations together, and you'll notice that the negative 2 plus the positive 2 causes that to cancel out. And that's what we're doing when we're using the elimination method to solve, is we're getting rid of something. And here we're getting rid of the y values, and I'll just add whatever's left over. So I've got 5x plus 6x. That gives me 11x. And then I'll add the two numbers over here to the right. The negative 2y and positive 2y have already canceled out, so I'm left with negative 7 plus 18, which gives me 11. And I will use that. Now you'll notice we don't have a y anymore. They've canceled out. We've just got an equation, a one-step equation to solve for x. 11 times x equals 11. Well, if I solve for x, just divide by 11 on both sides. So my x is going to equal positive 1. So we now know what the x value is in this equation. Okay, now I'm going to use that information to figure out the y value, because when we are solving by elimination, we're going to get the x value and we're going to get the y value. I want to actually figure out where these two equations, if I graph them, where would they cross? You know, at what specific point? Well, now I know the x value, and I'll go back to one of the original equations, whichever one. To me, I just picked the one that looks easiest to plug a number into. Here we have and I'm just going to pick this one. It doesn't matter which one I pick. But now that I know what x equals 1. Originally in this equation, it was 6 times x plus 2y equals 18. That was the original equation over here that we started with. Well, I know that x equals 1. I can plug x in. I can plug 1 in for x. Okay, so when I rewrite this equation, instead of x, I'm going to put, we already know that x equals 1. I plug that in. And now, once I've plugged in the x value, I'm just going to be dealing with an equation now that only has y's in it, because 6 times 1 is 6, plus 2y equals 18. Okay, so if I just keep solving this equation, solve for y, I'll figure out the y value. So now I'm just going to solve this equation, subtract the 6. Order of operation is in reverse when we solve an equation. So I'm going to subtract the 6, and that leaves me with 2y equals 12. Okay, and then to continue solving, I would just divide by 2 on both sides of this equation here. So I'm going to divide by 2 here, divide by 2 here, so y equals 6. Okay, so that's the y value. We already found the x value, and when you see your answer and you're talking about solving by elimination, it's going to be an x and a y. Well, as an ordered pair, x always comes before y, just like the alphabet. So the x value where they cross is at positive 1. The y value is at positive 6. That's where these 2 points, if I graph these two equations, that's the exact point coordinates of, you know, where these lines would cross. That's the solution to that system of equations. All right, and we're going to look at some special cases here. You're going to have equations that when you begin adding those two equations and you get something to eliminate, you'll notice here that we got a positive 2 and a negative 2y. Those cancel out. Well, here the x and the x cancel out. I end up getting 0. I have nothing left on this side. And then I add negative 16 and 11, and I get negative 5. Well, this is not a true statement. If you ever get something like this that does not make any sense, that's not a true statement. 0 does not equal negative 5. Okay, if it's not true, that's what we call no solution. Okay, so there's going to be, and what that actually means is that if I were to graph these two lines, a solution to these equations is where they cross. Well, if there's no solution, that simply means these are parallel lines. They never cross. There is no solution. There is no place. If I graph those two equations, they would just have the exact same slope. They would never cross. They'd go on forever. And there is no solution. Okay, so if you get an answer where everything cancels out and it just looks like something weird, 0 equals negative 5, if it's not true, it's no solution. And there is something similar to this, and we often confuse these two, is there are actually instances where everything's going to cancel out. Alright, so let's say, for example, I have these two equations here. I start adding these together, and it's like, oh, well, the x's cancel out, the y's cancel out, I'm left with 0. And then over here, my negative 20, my positive 20, they cancel out, and I'm left with 0 on this side. This is different, though. This is actually a true statement, because 0 does equal 0. And what that actually means is these are actually the same line. You know, a solution is where they cross. Well, if I graph one of these lines and then graph the other line, they would be on top of each other. They are the exact same line. So all that means is that there are infinite solutions. They always cross. And those two zeros here just kind of make the infinity sign around them. Those two zeros, if it says 0 equals 0, that doesn't mean no solution. That means these are actually the same line. They're on top of each other, and they always are crossing. So, or not necessarily crossing, but they are the same line. So that is infinite solutions if everything cancels out. Alright, now it won't always be so easy. You won't always have two equations where you add the two equations and they already have something that cancels out. Like in this case, we have a 6x, but we don't have a negative 6x. We have a negative 3y, but we don't have a positive 3y. So if there are not opposites, sometimes we have to create opposites. And the way we'll do that is through multiplying. We'll look for something that's easy to create. And like in other words, if I have a negative 12, well, what's the opposite of negative 12? Positive 12. So I look up at this equation up here in the top and say, okay, well, what can I multiply 6 by to make it the opposite of negative 12? And it's pretty easy to see that 2 times 6 is going to give me the opposite that I need. So what I'll do is I'll just multiply that. I'll say, okay, well, 2 times 6. And when I do that, though, if I change one part of this, I need to change every part of it. 2 times 6x gives me 12x, but I need to multiply everything in this equation by 2, because I don't want to change the value of just one part of it. I can multiply everything by 2, and I'm not changing the value here. 2 times negative 3y is negative 6y, and then 2 times negative 3 is negative 6. Okay, so I had to, and now I can just kind of ignore this equation up here. I don't need it anymore. I have created opposites, and so now I'm just going to look at this new equation that I created, and now I have opposites. Now I have something that will cancel out. So sometimes we have to do a little bit more work before we can go in and say, okay, now something cancels out. Now I can solve for y. And that's kind of just a little step further. And you'll also see equations, though, where you have to change two things. So let's go down and look at an equation where I can't multiply just 3 by something and get an opposite. You know, 3 times 2 is 6. It's not going to give me 4. And then look at the other numbers. I may have to, and this happens sometimes, where I have to multiply both equations by something to create an opposite. And the easy way to do this is to look at the numbers that you're given. 3, let's say I try to get rid of my x's, 3 and 4. If I multiply 3 by 4, it's going to give me the same thing as if I were to multiply 4 times 3. So I can just use that information. I can use that to help me get something to cancel here. So let's say I multiply this top equation by 4. That's going to give me 4 times 3. And then I'll multiply this bottom equation by 3. That gives me 3 times 4. Either way, it's going to create a 12. All right. Now the only issue is when we're creating opposites, I need them to have opposite signs. So if they don't already have opposite signs, just make one of those numbers negative. Okay, so if I make this a negative 4 and I multiply, and I'm going to be creating two entirely new equations here. Okay, so when I multiply this out, say I multiply negative 4 times 3x, that gives me negative 12x. And then negative 4 times 4y, that gives me negative 16y. And then negative 4 times 11, negative 44. Okay, so I multiply that out. Then I'll do the same thing with this 3. I'll multiply it to everything in that equation, and that gives me that positive 12x. That's what I was trying to get. I was trying to get two things that are opposites. I've got a negative 12x, and now I've got a positive 12x. That's what I was trying to get. Then I'll go ahead and distribute that out, and you'll notice now that these equations, I have two entirely new equations now once I've distributed this thing out. But I have created opposites. And these are the two equations that I will now combine to get something to eliminate. Okay, so sometimes you have to multiply one equation to create opposites. Sometimes you have to multiply both equations to create opposites. So I would still solve these exactly the same way we did the other equations. All right, and that's pretty much all there is to solving by elimination.